Hey guys, welcome to Code Decode. Today in this video, we will be looking into the transaction management in Spring Boot Hibernate application. The interview questions related to these. So let's get started. Please like, share and subscribe to support us so that these video reaches to more of the people who are trying to crack interviews like you. Now, how do you implement a transaction or how do you manage a transaction in the Spring Boot Hibernate application? So when you integrate your Hibernate with your Spring Boot application, you do not need to use any Hibernate transaction management. You can leave it to Spring declarative transaction management, and the way to do it using transaction annotation. Too much of theory. Now let's understand with the demo first and then we'll come back to theory. I'll give you an example. I have one Spring Boot project created for you. For integrating your Hibernate or JPA as an ORM into it, what we have done is in the pom.xml we have added one Spring starter dependency for data JPA, which will implement also the Hibernate in JPA for you. Now, the next thing that we have done in the application.properties, we have given the URL to connect to the database. Now, here you can see this is the code decode database that we are going to connect to. Then we have given the username, password, the delete and update. This is everything something we have already covered in the Spring CRUD video already. Next, we have created a simple flow that is from controller to service to repository. And the data that is going to be saved is created in the entity object. So we have two entities, employee and address. So employee has ID and name, and that employee details, the address details are actually here in the address table. So for each employee, we have an address associated with it with the address ID and address location. Say here it is name, it can be the address street 1, street 2 and street 3, something like that. This is just for a demo purpose. Now the employee is having the one-to-one mapping with the address. So we are just considering here that each employee stays at one single address and each single address is only one employee. So this is just an assumption for the demo purpose. Now this is the entities that we have created. Now let's come to the controller. So controller is the one who is going to interact first with our postman. We are going to hit a controller with the URL as localhost 8080/code/save. So 8080/code/save, and as the request body is employee. Now employee, we are just passing the name, not ID, because ID is auto generated. This is where the ID is auto generated. So it is going to be taken from the sequencing table. This is the Hibernate sequence where the next value is going to be taken to. So if this project status is clear, let's go to the service layer. Here service layer, we are passing an employee and we are saving it an employee as this. And apart from that, what we are doing, we are creating an address class. We are setting the ID, name and employee here, and then we are saving an address to. So for this we call an address service in the add address to in the address repository. So this is the complete flow. Just for the demo purpose, what I have shown here is we want to save both employee and address. So it should be in one transaction in one go. Now here what happens is as soon as line number 26 you save an employee and some exception throws, then address is not saved but employee is saved, which we do not want. The business says if an employee is to be saved, for sure there must be an address to be saved in the address table also. So for that, what we have to do is we have to make it transactional. Now I'll give you an example. If you do not make this method as transactional, then as soon as you complete your line number 26 and goes to line number 27, then your employee is saved in the database, which is EMP table. Here your employee will be saved. But that is not what we want, right? We want that when everything is completed, when address is also saved, at the end, both tables should have data if nothing goes wrong. Else you have to roll back and your data should not be saved in the database. So currently I can show you, if currently I do not have any transactional on the class or on the method level. So what will happen? So let me quickly debug this application. So application is started successfully. Now when I am trying to add this, then this is the employee, the ID is null because it is auto generated. Automatically it will be taking the next value from this Hibernate sequence. So 1, code will be saved. So when I do F6 and my flow goes to line number 28, in the employee table, since it is not transactional, 1, code is saved. So I'm removing everything, I'm closing it and I'm going to make it transactional. Now if I make it @transactional, then what does, okay, so from where we have taken it from Spring Framework's transactional annotation. So we are using the Spring declarative transaction management here, And what it will do, whenever you mark a method as @transactional, then when everything ended, when the closing bracket is reached, then only the data is added to the database. So that's the beauty of using a transactional. It opens a physical transaction to a database layer and will perform everything, keep it in the memory, and will update to the database only when everything is right. So now if I try to add it, now let me debug this application. After making it @transactional, as soon as you go to line number 28, you can see your employee is not updated in the EMP table. So currently EMP table is empty, address table is empty, and what is the Hibernate sequence? That is 1. So now if I try to add again, the code comes here, the name is code. Now if I do F6, at this point of time, in the previous example where we do not have @transactional annotation, employee is saved. Now can we see if the employee is saved? Answer is no, your empty table is still empty. It is because you have marked your service method as @transactional. Now until unless you do not reach to the end, nothing will be saved. So the table is empty. Now we understand that since we have integrated our Hibernate with Spring Boot application, all the headache of doing the transaction management is taken away from Hibernate and is given to Spring Declarative Transaction Management. And in Spring, we do the transaction management using @transactional annotation. So here we have used @transactional annotation to mark the boundary of transaction. As soon as the method ends, transaction also ends and the data is saved to the database. Now what all things we can use transactional for? We can use transactional to wrap a database transaction, a physical database transaction. So if you have marked a method as @transaction, until the scope of that method is not ended, nothing is going to be saved in your database. But as soon as the scope of this method ends, everything that you have done will be saved to the database. Now let me delete this right now and let's see the real example now. So we are allowed to do many things with @transaction. So currently what you have seen is, until unless the transaction boundary is not ended, your data is not saved to the database. Now let's see a good example of this. I'm going to start again. I'm going to set everything to empty. So employee table was anyways already empty. The Hibernate sequence, I'm going to make it to 1 again. And now let's try a happy case. So at line number 26, the data should not be saved as seen before. But at the end of line number 34, your data should be added in address table and in employee table both. So here's the method to add data to the address class. So I'm going to make this also transactional so that both of these are in the transactional boundaries. Now remember, this is the part of transaction propagation, that if you have an open transaction here and you call a method add_address and you go here, this is also in a transaction. So this is an inner transaction created if you have a propagation type. So propagation is how the transaction boundaries are managed when one method internally calls another method which is also annotated with @transactional annotation. So since employee method add employee is already annotated as @transactional and address is also annotated as @transactional, then there are multiple propagation ways through which you decide that this address to be added into table should create a new physical transaction, should use the existing transaction, or should not use any transaction. So all these cases are derived using the propagation field of transaction management in Spring. Let me debug this application. At line number 28, whenever flow goes here, your employee should not be added to the employee database. But after line number 35, employee should also be added and address should also be added. So here, when I do F6 and goes to line number 28, employee should not be added. So see, employee table is still empty because it is still a transaction in progress and method is not completed. Method is in progress and hence until unless everything is not done, nothing is going to be persisted to the database. Now I'm going to create an address object, and address object is going to have an employee reference to 1, code. Now whenever I go to address, now here this is also transactional. So current situation, address should also be empty. Even till here address is empty and employee is also empty. Now after this also, the scope of this is not ended yet. So if I do F6, we return to the employee class. Now here again still, since you have already executed address service, still your data is not added to the address repository. Why? Because we have used a default propagation. When there is no propagation, @transaction uses the default one. The default is the required. The required propagation is the default propagation type. It checks if there is an active transaction. If there is an active transaction, then use that. If it is not that, then create new. In our case, there was an active transaction coming from employee service. So it has not created a new transaction and happily ignored this annotation at line number 17 because a transaction was already open. Why to open another new physical transaction? Because there is a limit to creation of transaction connections to the database. So Spring does it internally for you. It does not create another transaction. So even when the scope is ended, the scope of this employee is not still ended. This method, which is the transaction being used, is not ended. It will end at line number 35. Hence your employee and address table both are still empty. If you can see, these both are still empty. Now if I end the transaction, now you try and see your data is added in employee as well as in address. This is the beauty of transaction management in Spring Boot. It does everything for you internally. What you have done, you have just added a transactional annotation here and you have used the basic propagation level that is required, which says if there is an active transaction with employee who is giving me already a transaction, why should I create new one? I'll use the existing one. And hence when it tries to save it, the data is not saved to address table. It is saved when the existing transaction boundary is ended, which ended at line number 35. Hence till line number 35, neither the address repository is able to save anything nor the employee repository is able to save anything. You are going to save everything only after the scope of this method is ended. So that's the beauty of transaction in Spring Boot. Now we have left lots of theory, and theory is also important. So I've already covered this. @transactional is used in the Spring. Even though you have Hibernate implemented, Spring is capable enough to do things for you. Now @transactional annotation gives you many ways to implement transaction in different ways. With the propagation levels, isolation levels, timeouts, rollbacks, read only, everything is given in this annotation as an attribute. Now it's so good to see it is working, but how does it works internally is a main question in interview. So internally, usually what Spring do is it creates a proxy or manipulates the bytecode. Spring will wrap some transaction management code around the invocation. So from where is it called? It is called from employee controller. So what Spring does is either it creates the proxy or it creates the dummy code. Whenever the add method is called, and if the add method is @transactional, then this controller is going to call a method like this. Create a transaction and call a add method with try and catch block. If everything is fine, then commit the transaction. If anything goes wrong or some exception occurs, then roll back the transaction and throw an exception. So this is the code that Spring does for you. When in this particular call from the controller, it calls a proxy or it gives a call to a dummy bytecode. A bytecode says, do not call this directly. Call this method in a block, and that block is a transaction boundary, a physical transaction boundary for a database. If everything goes perfectly fine and the add method is ended perfectly fine, then only commit. This controller says after this is completed, after that commit. And this whole line is replaced by these line of codes with try and catch. So in the try, add is called, and then after that commit is called. If anything happens wrong in the add block, then a rollback is created for you. How to use @transactional, where you can use @transactional. You can use @transactional on the method level, on the class level. So this is the class level. So you can use transactional here also. And if you use transactional here, by default, all the public methods will use this @transactional automatically. So if you do not make it @transactional, by default, all the methods will create a transactional boundary. So you can use it on interface, superclass, class, method, or superclass method, or method level. Now we are considering Venus class and method level. If you have a class level annotation, you do not need a method level annotation. Basically, both of them will use, all the methods will use the transactional only. But if you give both, you have @transactional on class level also and on the method level also. Who will be given the preference? Always the method level transactional will be given the preference. So here is an example. Your employee service is also annotated with @transactional. and your add method is also annotated with the rate transactional. Then the method in the class takes the preference over the transactional setting defined at the class level. So remember, if you have transaction on both, then who works? The method is given the preference. Now a quick check on your theory. What is transaction? What are asset properties? So a basic transaction is a way to make changes that you perform in one or more systems. So currently we are making changes in two systems, the employee table and the address table. So this transaction is a way to maintain a transaction across these two systems. So a transaction manages the changes in one or more systems, in our case employee and address table. These can be databases, message brokers, or any kind of software system. In our cases it is database tables. The main goal of transaction is to provide the asset characteristics. And what is asset characteristics? Atomicity, consistency, isolation, and durability. Atomicity defines all or nothing principle. So it means if you commit your transaction, then you can be sure that all your operations got performed. But in case you abort your transaction, then everything that you have done is going to be rolled back. Nothing is going to be saved in the database. So this Hibernate transaction makes sure everything is atomic in nature. Then we have consistency. That means this transaction that you are doing is going to take your system from one consistent state to another consistent state. For example, if you are doing some bank transaction, then if the data is deducted from my account and added to your account, then it will not happen that it is deducted from my account but not added to yours, or it is added to you but nothing is deducted from my account. That cannot be the case. So the consistency says at the end your data is consistent. If 10 rupees is deducted from me, 10 rupees is added to yours. In relational database, that can also mean that all the constraint checking is also passing. That is, the foreign key and unique key constraint is passing in your database. Now isolation. Isolation means that your one transaction is not visible to another transaction until you commit. Otherwise you will have multiple problems like dirty read, phantom reads, read uncommitted. All such isolation levels we'll be seeing in next few minutes. Then we have durability, that ensures your committed changes are persisted in the database. So if you do everything, your old logic is written, everything is doing fine, but after line number 36, your code is not added to the table. Then what is the use of doing that much? So durability says your data is going to be committed and persisted once you commit or you exit your transaction boundary. So by the end of this boundary, for sure your data will be persisted to the database. Now transaction propagation, I've told you. If there is one transaction already open and you call a method inside a method, then, and that is also a transaction enabled, then how boundaries are managed, the physical boundaries are managed in Spring. So there are multiple ways to decide your logical transaction boundaries with the propagation levels. The first one I've already shown you. The transaction propagation is required. This is a default propagation. It checks whether an active transaction is there. So this has a property called as propagation. And it has a propagation type. It says if there is an existing transaction coming. So yes, existing transaction boundary is already coming here at line number 33 where it is getting called internally. So at line number 33 when this is called, a transaction is already open. So this is conveniently ignored at line number 17 and the same transaction is used, and hence even after line number 21 ended, this transaction boundary is not even created ever because it is propagation type required. This new transaction is not created, and only when at line number 36 when the transaction boundary ended, then only both the employee and address is saved. Even if you cry and hard and say repository.save, nothing is going to be saved in your table because the transaction is still open and running, the main transaction. So that is a required propagation. Now let's see another type of propagation, requires new. Now requires new, say I want my own complete transaction. And what is the keyword for that? Rather than required, it was, so these are all the annotations that we are going to see. Now I will be demonstrating requires new. Requires new says, okay, if there is a transaction coming, I have a problem. I want my own transaction. I don't want to use anybody's existing physical transaction. I want to create my own transaction. So suspend the previous one. So employee transaction will be suspended and a new transaction will be created with employee new. And when at line number 21 everything ended, the address will be saved in the address table. Employee will be, after completion of line number 36, employee will be saved in the employee table. So these are not dependent on each other. After line number 21, initially with required, address was not saved. But here address will be saved. But one catch here is that if you try to save an address before an employee, the table does not work like that. If you go into that address table, it has a foreign key constraint. If you go into the properties into foreign key constraint, EMP ID is referred from employee, and since employee's transaction is not added, anything will not be added in the employee table will be empty. So it will give you an exception. To prevent that and to showcase a require new propagation type, I will comment this up so that there is no foreign key relationship which can cause a trouble to our program. So I am going to comment this right now, and what I am going to say is save an employee after line number 36, but before that add an address. Now this add an address says and require a new transaction. So at line number 21, a new address will be saved. Now let me try hitting it. So at line number 29 again, your employee which is saved will not be added into the database. Why? Because the boundary is ending here. But before that, if you can see, our address class is called, and the transaction propagation says I require a complete new transaction. So what it does is it suspends the thread which is saving an employee to employee table and started a new thread which is going to add an address to the address table. We have an address with me, ID1 and name as Bangalore Whitefield, and when line number 21 ended, at least address will be saved. So after line number 21, you can see our address service is done, but our employee services is still remaining. It is still not there. So employee should be empty, but address should have the data now. So yes, address has the data now, though employee ID is null because I have commented the code. But at this point of time, I can showcase you that address service boundary is ended because a new transaction was created. A boundary ended at line number 21. Hence, address has the table, but employee is still empty. It does not have anything. When will employee table has the data? After line number 36 is executed. And when the line number 36 is executed, even your employee has the data. So this is the employee, and can you see the Hibernate sequence to be moved to 3? So what happened here is employee 1, code was in the memory. Hence, the address was saved as 2 because both uses the Hibernate sequence only. So though I have added the employee at the end, but the employee was created first. So during the save only, the Hibernate has created an employee with the ID 1 and later an address with the ID 2. But since you have created a new transaction here, hence address was saved first and then employee was saved. But what you have in the memory is 1, code and 2, address. So that was requires new. So that was all about requires new. I have many more things to cover like nested, mandatory, never, not supported, supported, rules for transaction, isolation management, what are isolation levels, and how do we implement that in Spring. So if you want me to cover all these remaining topics, please let me know in the comment section. Then only I'll create the second part of this. Thank you.